Alright, so what I want to talk about today is going to be order of operations. Let me get over here and get a half decent color to use. Alright. So we're going to look at order of operations. And what happens is the things that we use in mathematics tend to be called operators. And they're usually two-sided. You have something on this side and something on this side. And the operator tells you what to do with the two parts. Sometimes called binary operators because it's binary for two. And the ones we tend to have that we use often, though there will be more, is plus or minus, multiplying, which we can do as x or a dot, and division, which we can do as the division symbol, the fraction bar, or even in a long division symbol, right? We have multiple symbols for that operator. And then powers, where we have something with a power, and roots, where we take like a square root, something with a root and a power. And we have then in parentheses and different grouping symbols, like we have curly brackets, square brackets, parentheses, that we can use to group things together. And so these aren't operators, but these are group. And so all said and done, we name these operations and operators. We'll say addition and subtraction are related. Multiplication and division are related. Exponents and roots are related. And then those parentheses or grouping symbols come up top. And I'm writing them in an order with a top and a bottom. And we do things up top first, and we do things in the bottom last. And what happens is operators are kind of defined off of each other. So addition, A plus B, and subtraction can be the same thing. I can say A minus B, oops, I don't want this to be equal, is the same as A plus this opposite of B, if I put a negative sign to B. And so addition and subtraction have kind of a related meaning. They're built off of the same components, so they are on the same level. But if I want to multiply, let's say I want to add 3, I want to add 3 again, I want to add 3 again. If I do multiple additions, we turn this into the term of multiplying, so that would be 4 times 3. So multiplication is built out of addition. Because it's built out of it, it's higher up. And 4 times 3 is 12. Well, we can reverse that. We can say 12 divided by 3 is 4. And so it is related, division is related to multiplication. In fact, if I say I have A divided by B, that's the same as A times the reciprocal of B, 1 over B. And that gives me the same thing. So because division and multiplication are built off of each other, they're on the same level. And I can do something even crazier. I can say 2 times 2 times 2 times 2 times 2. I can multiply multiple times. Well, how many times did I do that? 1, 2, 3, 4, 5. And I say that's 2 to the 5th. And that's my power. And so that's 32. Well, I can also take a root. And so let's say I had 3 times 3, which is 3 squared, which equals 9. Well, the square root of 9 is 3. It's going backwards with roots. This is a common thing that happens with our mathematics, is we define something to go forward to give us a particular answer. And then later on we go, well, where did that answer come from when we go backwards? And the same thing happens with exponents and roots. So they're on the same level. And then parentheses and grouping lines are something that we do to help keep things in order. Now, there is no rules in numbers themselves that tell you the order we do these in. So we had to invent a way that we were always going to talk about it. And from that we get PEMDAS, P-E-M-D-A-S. You do the parentheses first, then the exponents, then multiplication and division are on the same level, and addition and subtraction are on the bottom level. And so PEMDAS becomes the way that we work these out when we want to. And so what can happen is we can get an expression of different operations. I can get 10 plus 18 divided by 3. Let me get my full operation here. Oops, I apologize. It's divided by 6 times 3. So let me rechange here. Divided by 6. Times 3. Minus 2. And there's many different ways we could do this, and the answers change upon it. And so we decided to use that PEMDAS, so I'll write it down here again, P-E. I'm going to keep R for roots. We won't get roots for a while, but we'll see them come up as we work with different parts in the statistics where we need to take square roots. And addition and subtraction. And so what we want to do here first, from left to right, are any parentheses, which I don't have any powers, which I don't have any, but now I need to do my multiplications and divisions. So I do 10, well, the first division I get to is 18 divided by 6, which is 3. And now I come back and go through again, and I have to do 10 plus 3 times 3, which is 9, minus 2. And now I don't have any more multiplications and divisions to do, so I come across and do my additions. Again, I'm moving left to right, like we read, to avoid any ambiguity. And I do all the multiplications and divisions first, and then I go back and do all the additions and subtractions. So 19 minus 2, or 17. And so we're able to get consistent answers coming out. And then the other thing we can do is, if we're not certain of a value, or we want to do a particular portion first, we put grouping symbols around it. So let me change colors here. Scroll down a bit. Let's say there's something where I'll actually put it in an actual example. I want to figure out what the area is of a rug. And so that's the length times the width will be the area of the rug. But I can't measure all of this at once. I have to add up parts of it. In fact, I add up half of it because I get a tape measure, and my tape measure runs out at, let's say, 3 feet. And then I come back and I get 2 more feet. And so I have to add these 2 parts first before I do the multiplication. Now, normally I do my multiplications first, so I've used parentheses, I say, and we'll say it has 2 feet here. And so my width is 3 feet plus 2 feet, and my length is 2 feet. So I have to do the 3 plus 2. I put it in parentheses saying I want to do it first, then I multiply by 2. Otherwise, if I wrote it 3 plus 2 and wrong, this is going to be wrong, so I'll put a bubble around it, times 2, I would do this first. That's not what I had to do when I measured it. I had to add first. And so I use parentheses to say I'm adding first. And so I get 5 times 2, which is 10. That gives me the area. And so parentheses are kind of a way of saying we know we have to do this work first, even though our symbols tell us not to do it first. So I've included a worksheet on order of operations. Practice it. A thing to pay attention to is we sometimes have some parentheses we don't talk about a lot. We use the fraction bar as a division. So if I have 4 plus 8 divided by 3, I know I want to do division first, but these don't line up. And secretly underneath all of this, this is saying 4 plus 8 divided by 3. There's silent parentheses when we use a fraction bar for division. We look at the top as one thing and the bottom as one thing. The numerator and the denominator is 2 things. and we build them back into a fraction. So just keep that in aware. When you see these fraction bars, there's these hidden parentheses in there that group the top and the bottom together. Practice the worksheet. If you have any questions, send me emails and I'll try to record some videos that go about those questions.